All right, so the next rule we'll talk about is the zero exponent property. So we'll start with this example. If we got 3 to the fourth over 3 to the fourth, if we want to write this as a multiplication question, it's 3 times 3 times 3 times 3, 4 iterations of 3 in the numerator, over 3 times 3 times 3 times 3 in the denominator. And when we cancel everything, each 3 cancels with each 3. We're basically going to be left with like nothing left in the numerator and nothing left in the denominator. Okay, this is not 0 over 0. What it really is 1 over 1. Okay, so what would happen here if we did this like using our division rule that we talked about in rule number 2, or rule number 3 rather, this is the same thing as 3 to the 4 minus 4, which would give us 3 to the 0 power. And here's the takeaway. If you have any number raised to the 0 power, it is not equal to 0. It is equal to 1. Okay? For every non-zero number, a raised to the 0 power is equal to 1. Anything raised to the 0 power is equal to 1 unless it's the number 0. Okay? So if we look at example A, we see -6 raised to the 0 power. As soon as you see this exponent of 0, you cannot think the answer is 0. The answer is equal to 1. It is just that simple. So we have 14 to the 0 power times x, y cubed. 14 to the 0 power, same thing as 1, but I still have an x and a y cubed after it, okay? X is being raised to the first power, y is being raised to the third power. It's the exact same thing as x, y cubed. 14 to the 0 power becomes a 1. For letter C, w to the 0 is equal to 1. Z to the 8th stays z to the 8th. This is the same thing as 1 over z to the 8th. Okay, we'll keep going here. So for letter D, there's a bunch of stuff going on. We've got some numbers. We've got a w raised to the 0, r to the -6th, and r to the -9th. So here's what we're trying to do. We're going to try to like break this up and compare or combine the like terms. So the first thing here I see is the numbers. The first thing I see here is a 5 over a 10. Okay, there is a way we can simplify that. If we have 5 over 10, that's the exact same thing as 1/2 after we simplify. The next piece I see in my numerator is w to the 0 power. Okay, we already know that w to the 0 power is the same thing as 1, so it basically just goes away. It doesn't cancel or zero anything out. It just becomes 1. And then the next piece I see is r to the -6th in my numerator, and then r to the -9th in my denominator. Okay, here we have the same base, so we can, because it's division, we're going to subtract the exponents. If we have r to the -6th minus -9, that's going to become r to the -6th plus 9, which becomes r cubed. It would become r cubed in my numerator. So it's 1r cubed over 2. For letter E, what we notice here is that we got this big ugly fraction and it's all being raised to the 0 power, okay? So whatever is inside of here is being raised to the 0 power. Anytime something is being raised to the 0 power, it's just going to spit out a 1. So even though it looks super ugly on the inside, as soon as you do all your simplifying and canceling, it's being raised to 0 power. And anything being raised to 0 power is equal to 1. No need to do extra work if you don't need to. But letter F is slightly different. So I want us to compare letter F to letter A. So in letter A, the entire number -6 was being raised to the 0 power, and it spit out a 1. But what's happening here is actually just the 6 is being raised to the 0 power, and then there's a negative outside of it, okay? So if we account for order of operations, the first thing we have to recognize is, okay, what's being raised to the 0 power? Just the 6. So 6 to the 0 power becomes 1. But then what's happening is this entire thing is being multiplied by a negative. So my answer here is -1. Kind of tricky. A lot of people mess that up. Please don't get confused with your parentheses. It does make a difference here. If your entire negative quantity is being raised to the 0 power, it becomes +1. But here, it's 6 to the 0 power times -1, and that's why it spits out a -1 total.